All right, so we have here, it says use properties of logarithms to condense the logarithmic expression. Write the expression as a single logarithm whose coefficient is 1. Where possible, evaluate logarithmic expressions. All right, so here we have the natural log. We have ln of x plus ln of 6. Because this is an addition sign, we're going to use the product rule where we're going to multiply. So we would write this as ln of 6 times x, or we can say ln of 6x without the times sign there. Next example, we have here log base 3 of 405 minus log base 3 of 5. This is subtraction. So we're going to use the quotient rule. So we write this as log base 3 of 405 all over 5. Now, let's divide. We can divide 405 by 5. Let's go ahead and divide that out. Okay, so we have here, let's clear this screen here, 405 divided by 5. That gives us 81. So we have log base 3 of 81. Now let's take this expression here, log base 3 of 81. Let's see if this can be simplified even more. So we're going to set log base 3 of 81, set it equal to x. Okay, I can move the calculator out the way here. And then let's write it in exponential form. 3 to the x power equals to 81. So what number could we plug in here for x as an exponent with a base 3? 3 raised to what power would give us 81? Well, x would have to be 4 because 3 to the 4th power, multiplying 3 4 times, that would give us 81. Therefore, log base 3 of 81 is equal to 4. Let's do another example. All right. So we have here log of 4x plus 5 minus log of x. So we have a subtraction sign, meaning we're going to use the quotient rule. And we will write this as log of 4x plus 5 all over x. Now remember, when there isn't a log, a base there, is understood to be 10. Okay, so this is all we need for right now to do. That's all we can do. This cannot be factored. Please do not try to divide out the x's. The only way that you can divide out the x's if the numerator was all multiplication. Because we have two terms, this is a binomial, so we cannot reduce this 4x plus 5 all over x. Next example, we have here log of y plus 9 times log of z. So the first rule that we're going to use, because we have a 9 in front of this log, we're going to use the power rule. Okay, so log of y plus log of z to the 9th power. And because this is a plus sign, this is addition, we're going to use the product rule. So we will write this as log of y times z to the ninth power. There we go. All right, so the next example, 8 times log base b of x plus 5 times log base b of y. First, we're going to use the power rule because there is a number 8 and then there's a number 5 in front of each log. So let's write this as log base b of x to the 8th power plus log base b of y to the 5th. And just like the previous example, because this is an addition sign between each log, we're going to use the product rule, meaning we're going to multiply the logs together. So our solution, we have log base b of x to the 8th, y to the 5th. And there we go. Now you can write it with or you can write it without the parenthesis, but these are together. The x to the 8th, the y to the 5th. Next example, similar to what we just did, but this time instead of the written word log, we have the natural log ln. So here we go. We're going to use the power rule first. So we have here ln of x to the third. Let me read the question. 3 times the ln of x minus 5 times ln of y. So we have ln of x to the third minus ln of y to the 5th. Now this time, because it's a subtraction sign, we are going to use the quotient rule. So we will write this as ln of x to the third power over y to the 5th. And this is condensing the logarithm expressions or logarithmic expressions. All right, here we go. So anytime we have a number in front of the log or the natural log, we're going to start off by using the power rule. So this next example, 9 times ln of x plus 5 minus 4 times ln of x. So we have here, using the power rule, ln of x plus 5 raised to the ninth power minus ln of x to the fourth. And because this is subtraction, we're going to use the quotient rule, and we will write this as ln of the quantity of x plus 5 raised to the ninth all over x to the fourth. And that is all we can do. And then our last example, same rules apply. Okay. We're going to start off with the power rule. We have 6 ln of x plus 4 ln of y minus 2 ln of z. This gives us ln of x to the 6th using the power rule plus ln of y to the 4th minus ln of z to the 2nd. Then we're going to use because we have a subtraction, we're going to use the quotient rule. Ln of x to the 6th plus ln of y to the 4th all over ln of z squared. And then we have the addition sign in the numerator. We're going to use the product rule. So we have here ln of x to the 6th, y to the 4th, all over z squared. And there we go.